Hey, everybody. I'm Tracy. It is 11 o'clock, which makes it our official startup time. I want to welcome you to this INE live webinar, and it is on AWS Well Architected Framework. And it's a practical application approach to this. And I'll explain what's going on with that. This was really something, quite honestly, that I just kind of wanted to do as I make my way more towards a broader cloud environment. And also, quite honestly, we are very happy that we now have an AWS expert on staff who is going to start building more AWS content. So I thought rather than put him on the spot, I would go ahead and do a little bit and kind of talk about why this is and what the Well Architected Framework is. But also, honestly, I wanted to take a look at it from an approach, from a standpoint of someone who is not an AWS master, so to speak. And so, speaking of which, I'll just introduce myself a little bit. I am Tracy Wallace, and it's kind of weird you can see me here and in the photo. Gray hair in both cases, a little more of it in that particular photo. This is my my pandemic haircut that I'm going to try and keep forever. The reason why I want to show you this is because it does have my contact information. Please do not hesitate to reach out to me. And if you've got questions about this or anything about INE, I would be more than happy to handle that. Now, so you know, this is coming from someone who is a cloud. I think I could probably, I hate calling myself an expert, but I think I could probably qualify as a cloud expert. But that's really been over 10 years in Azure. And over the last year, I've been kind of dabbling in AWS. And a couple months ago, I actually went through and studied and achieved the cloud practitioner certification in AWS. So I've got kind of a weird mix of experience when it comes to AWS because I've got a lot of cloud general knowledge, which absolutely helps me in AWS, but not necessarily that expert level in AWS. But again, that's actually the point of this webinar. It's why I wanted to do this webinar, is because I wanted to take a look at something that is really pervasive in the AWS environment, and that is the well architected framework. Okay. And that is something I wanted to look at. Now, hang on just one second. All right. Now, it is entirely possible that I kicked things off a little bit early, and we may get broken into here with a more professional start to this. But I figure, might as well get started. Anyways, I'm going to kind of go back to where we are. All right, we're totally good there. At the end of this, by the way, there definitely is some housekeeping stuff and some announcements. I want to make sure that we hit that, and I'm being told to make sure that we cover all of that, which is fantastic. I will say, for those of you that are on via Zoom, if you have questions, do me a favor, post those questions in the Q&A. And I keep an eye on the Q&A. It's a lot easier to see those questions come in than to see the questions necessarily coming into the chat. So absolutely love answering questions. I'll be happy to answer some questions. Just, let me know, what the questions are by putting them in the Q&A. I already have a Q&A question. Fantastic. The question is, what time will this conclude approximately? And the answer to that is I have absolutely no idea. No, these typically run about an hour. So we started at 11 a.m. Eastern Daylight Time, and I would expect it to complete by 12 p.m. or noon Eastern Daylight Time, probably at the latest. Okay. So I'm going to move off of my face because it's kind of weird looking at myself, and we'll move into the agenda. So I'm taking a look at the Well Architected Framework. And while we're on the agenda, again, I started to talk about this and then I sort of interrupted myself. But the Well Architected Framework is this system that AWS has. It says, look, if you follow this, you're going to build good cloud applications. Okay. Well, my thought is, hey, I know the cloud reasonably well. Again, I know it from a different perspective, and I've been building applications I don't think I can count the first one I wrote on when I was like 12 on a TI-99 4A. If you don't know what that is, don't worry about it. It's a really old computer. But that probably doesn't count. But I've been building applications and writing code professionally for over 30 years. And so I said, okay, I write code. I've written production applications. I've been parts of teams to do that. I know the cloud. So what is this well-architected framework thing? Okay. And what I thought I would do is say, okay, again, it's this process that they have laid out. We'll talk about that in a minute. That says, okay, you follow this process and you're going to build good cloud applications. All right. Okay. Well, if I want to do that, I'm going to take an application. And what I'm doing for this webinar is I'm taking an application that, quite honestly, I build a lot. And it's my starter application anytime I want to try and figure something out. I used to, years and years ago, when I was learning a new thing, I would start out with a checkbook. And my poor wife put up with new versions of different checkbooks in different environments. And then finally she said, okay, enough of this. We're going with somebody else. And that's fine. I had to come up with a new demo. And so I came up with this demo of a quiz management system, right? And so I've got this idea, and I've implemented it a few different ways. Obviously never completely, because otherwise I'd be sitting up there as quiz king of the world. But kind of had this idea of saying, look, I've got this practical application that I want to build, and I know the application. I know the way I want to build it. Well, what if I took that application concept and I applied this well-architected framework to it, right? And what would be the impact of doing that? And that's really what this webinar is about, is taking a look at that, saying, okay, let's start out talking about what the well-architected framework is, okay? And not spending a lot of time on that. This is a webinar. We're not diving deep. All right. But certainly that's something that, honestly, at INE, we're building into the training that we're building up for AWS. Very excited about that. But this is a webinar. It's short. So we'll look at what it is in the very broad strokes, and then we'll look at applying it. And that's really where most of this webinar is going to focus. And I'm going to talk about the workload, this quiz application, and then say, okay, what would be my first cut? Having gone through the basics, having read the kind of high level concepts of the well-architected framework, how would I apply that to this workload? And then say, okay, if I did that, let me look at this. Let's break this down a little bit. How would I generate a cost estimate for how much it would cost for me to deploy this in the cloud as a well-architected solution? And it's a huge guess, I'll be honest with you. We'll talk a little bit about that as we go through. Then, after I've gone through and I've said, I've got a really well-architected solution now, then I'm going to go through a tool, an expert system, that's going to walk me through the process of actually seeing how well-architected my solution is. And, well, I'll be honest with you right up front, it's not great. It's not terrible, but it's not great. And we'll look at that. And say, okay, we have all that. Then what I want to do is say, okay, based on this process, I'm going to show you just a couple of things I did coming out of the box. Initially, my initial thought for this 1 hour webinar was that I was going to build this thing full out. Right? That wasn't necessarily fully rational. So I built a few things out just to kind of get a feel for it. And I want to give you my feedback on where I thought that was. And then I want to talk about the changes overall, both the initial changes, that initial cut. So, okay, what would be the impact of making the changes to go from what is frankly a very pretty simple, but also completely non-scalable solution to a at least marginally well-architected framework? And then what would be the additional changes that would be needed for that to really be compliant with the well-architected framework? And then also, I have lessons learned, next steps there. We'll talk a little bit about that, but I kind of want to look at the impact of those changes. And I've got it laid out, like, okay, how much time would implementing the well-architected framework, how much time and effort would that add to the overall development process? Because to me, that's important, right? So, okay, I'm gonna go in and I'm gonna buy into this well-architected framework. It's gonna give me a lot of good things, but what's the trade-off there, right? And I've tried to kind of quantify that, at least, from my experience and where I am. And obviously that's just a cut of someone who is, again, pretty familiar with cloud concepts in general, but not necessarily expert as they apply specifically to AWS and specifically for the well-architected framework. All right, and so that's what we're going to cover here. And without further ado, let's go ahead and jump right in. All right, so first of all, what is the well-architected framework? And I will tell you, for copyright reasons and also just because, this is directly from the AWS documentation on the well-architected framework. So what is it? The well-architected framework describes the key concepts, design principles, and architectural best practices for designing and running workloads in the cloud. Simple. That's what this is. It is a system. It actually started out that this system was a single white paper. And it's really gone from that white paper of, hey, here's what you should do in AWS to again, really kind of a system, documentation as well as tooling, which we'll talk about. Also, by the way, if you're on the Azure side of the fence, just so you know, they have an eerily similar process on the Azure side. So I didn't go that route because, again, I kind of wanted to go more from the, okay, how's this really going to impact me coming in somewhat cold? All right. So what is the well-architected framework? First of all, there are 5 broad pillars, and we're going to talk about those pillars in a moment. There's very detailed guidance within each one of these pillars regarding the things that you should do in order to end up with a well-architected application or really system environment. It is based on experience within AWS. So field engineers, architects, and the partners that they work with, designing good, solid, reliable applications, systems, workloads that are running in AWS. Again, I mentioned it started as a white paper. Also, there's a free, what I would consider to be expert system, and it's called the Well Architected Tool, which to me is a little bit ambiguous. Is it a tool for designing well-architected systems, or is it just a tool that happens to itself be well-architected? It's the former, but that's just me. And it walks you through a series of questions, and we're going to take a look at that and say, okay, what is the status of your architecture for whatever your workload is that you're defining or really looking at there? And then it's going to generate a report based on a set of risks. So based on your answers to this tool, it's going to come out and say, okay, well, here are the areas that you're probably going to be at risk, and it's going to have severe and it's going to have medium level risks. And it's going to talk about mitigation approaches that you can take for those risks. So it's really a good guide. And I'm going to jump ahead a little bit and say that it is absolutely a tool that, if I continue to push a journey into AWS, I will be using on a regular basis. I think it's a very practical tool. All right, so what is the well-architected framework? Okay, there are 5 pillars. One of those pillars, I'll say the first pillar, it's not really the first pillar because they're all equal, it just happens to be the first one we're looking at, is operational excellence, right? So you are going to deploy a workload into the cloud, into AWS. You want to make sure that it is running and it is monitoring and it is being monitored and it is delivering value. Now, what are some of the key design principles? First of all, you want operations as code. And this is really an extension of the concept of infrastructure as code. All right, and we'll talk a little bit about that as we get into the practical implications of this. That says, look, what you really want to do is you want to have as much of your operational capabilities that are codified, all right, and that can be reproduced easily. All right. Also, you want to look at things like small, frequent, and reversible changes, right? So, kind of an anti-waterfall if you're a developer, that you want to not wait till everything's updated. You want to update frequently, which is very much the operational approach to cloud in general. It's the cloud providers. It's the way they work. They're changing all the time, but they're little changes. Frequent refinement, that kind of goes with that, right? Saying, okay, you want to have your workload set up so that you can change it a lot, you can refine it, you can always make it better. Make sure you anticipate failure, right? And that's something that, and I don't have the exact quote, but it's something that's pretty well known within the AWS environment, is you build with the assumption that everything fails. And you build for that and you learn from that, right? So that's the first one, which is operational excellence. The next pillar that we're going to talk about is security, right? And that's probably pretty straightforward conceptually, although absolutely huge in its implementation. You want to protect your information and you want to protect your systems. What are some of the key design factors? Strong identity, traceability of activity, provide security on all layers. And I think this is one of those things where I think a lot of the security professionals that I know, if they could just get us as developers to do that thing, that they would be able to get a lot more pleasant hours of sleep at night. Also, in terms of security, automate your testing, automate your monitoring of it. Make sure that you are securing both at rest and in transit. And separate people and data. That's an interesting concept. And it's something that I was happy to say, hey, that's one I've always lived by, right? I never, ever want users, I don't even want administrators having direct access to the data. I grew up, if you will, professionally as a database administrator. And, one of the things that I would always talk about when I would teach people about databases, is when I would talk about transactions in general and databases, relational databases. It would be like, inevitably a database administrator is asked to go, directly to the data and make some changes. And after they've lost their first job for doing that, they learn about transactions and making sure that they always do everything in a transaction, which if you're not a database person, I've just put you to sleep. But the point is that, you from a security standpoint, and frankly, from just an overall operations standpoint, I never want people going directly to the data because I always want my business rules, my security rules applied to the data. So separate that out. And interesting, this is one that's pretty cool. And again, just to put a shameless plug out there for INE, one of the things we've done recently is we've added a lot of expertise on in-house expertise on cloud blue teaming. If you're a security person, right? Looking at, incident response and identification and preparation. And so, that's something I think is pretty universal, and it's a pretty cool topic. All right. So what's the next pillar we have here? Reliability. Make sure your stuff runs, right? Make sure it performs correctly. It performs consistently. Some of the design items here: recover from failure automatically. Test recoverability. That's always good. Scale horizontally, and that's one that is always of interest to me. One that I think is actually kind of difficult, and I'll talk about this a little bit. And I will tell you, it's one that I certainly am not 100% there on yet, is stop guessing capacity. Okay. That's something that is actually a tenet in general within AWS. And the idea is that, you don't have to go out and buy millions of dollars worth of hardware on a predefined assumption of what your capacity needs are, right? It's so easy to grow your capacity and frankly to shrink your capacity in the cloud that you want to build that in. And it's interesting to me that kind of comes up under reliability. Also, automate changes, right? And so inevitably you're going to need to update, right? Make sure whether it's your workload itself, your code, if you will, or the infrastructure, the resources that you're using to facilitate that you're really automating any changes to that. You never want somebody to have to go in and type out a CLI command, click a button to update your code. You want that to be an automated process as much as possible. Next is performance efficiency. Use things correctly. To me, this is kind of tied, the next two are kind of tied together, right? Make sure I know what my compute requirements are is really what that comes down to. Leverage the cloud, right? Use the cloud and use the features of the cloud. And I'll go into this and why I think that, part of what I did to get ready for this was actually to go through the certified cloud practitioner, because in order to effectively use what's in the cloud, you have to understand the cloud. Also consider going global. That is something that is just absolutely part of the DNA, if you will, of cloud, right? Your cloud providers, honestly, it doesn't matter whether it's AWS or Azure or Google Cloud Platform or DigitalOcean or anyone else. You're looking at having a global footprint from the cloud provider. You can use that. It is literally just as easy for me. I live in the East US. It is just as easy for me to spin up a workload in East Asia as it is for me to spin up a workload in the East US. And that gives me this opportunity to look at my workload globally, to look at my potential customer base globally, and not really have that impact the cost of my architecture, the cost of my implementation. And that's pretty impressive. Be serverless. Here's another one that I absolutely love. And it's something that, quite honestly, I'm not a huge fan of the term serverless because there's always a server, but I am so on board with the concept. I'm going to take a step back. I'm a developer at heart. Now, it doesn't mean I go out there and bang out code all the time. If you start talking about Golang, I'll say, yes, I know what that is. But that's where my heart is. I want to build a solution, and honestly, I don't want to have to think about anything underneath of my solution, my workload. That's all I want to focus on. So for me, the concept of going serverless, not having to worry about the operating system, not even having to worry about the services that are supporting my workload, is absolutely something that is 100% in line with where I am. Now, that doesn't mean it necessarily is with you, but I would definitely consider that. And it ties in, again, a lot of what's on this pillar ties into the next. Experiment, okay? And that is something that I will tell you, particularly as an instructor, again, the cloud is built for. I can't tell you how many times I've gone in, I've had discussions with people that want to do some on-prem stuff, but then they're thinking about all of the on-premises resources and hardware and configuration. And I'll take a step back. I've got this. And I can just go and pop it in and experiment with it and set up an experiment for them in the cloud, right? And in fact, I'll tell you right now, I've got actually 3 different experiments that are going on that I'm supporting in the cloud, right? Because it's so easy to do. And so that's something that is there. And I can tell you, again, not being a AWS wizard yet, is something that is absolutely there. And this one I like a lot, mechanical sympathy. Great term. But beyond that, what that's about is it's about picking the right technology for what you need to do. And it's something that I actually thought about for this webinar. And actually, it's something that I've decided I'm absolutely going to build my solution. And one of the reasons is because I've changed it in a fairly significant way to say, you know what, I know, again, my solution being this quiz system, I know the data structures for a quiz system, and I've always done this with a relational database backend, but in reality, there's a much more logical and natural fit for it. And so it's really easy to use in the cloud. I'm going to go ahead and do that. And I'm going to talk about that a little bit more when we get there. Okay. The last pillar, again, it's not the last pillar in any sense other than the fact it's the last one I'm presenting, is cost optimization. Avoid unnecessary costs. Now, look, AWS, as is the case with Azure, is the case with Google Cloud, they want your money. They do. But also, they're very smart, and they know that if people repeatedly use their system and realize that they're spending a lot more money than they should, that's bad. So, both just philosophically, but also very practically, AWS is really very dedicated to making sure that you're not spending more money than you have to, right? They want you to spend your money with them, but they certainly don't want you to spend more money than you have to. Okay? And so what are some things you need? Well, first of all, you need to learn cloud financial management. I will tell you, a huge one for me in AWS. Not too long ago, let's just say, without going into details, I was hit with a bit of a bill I was not expecting from AWS, and my cloud financial management is much better now. Doing things like setting up budgets, setting up alerts, monitoring your costs. Go with a consumption model. And for me, that is very much tied to performance efficiency. And what that means is that when possible, you want to pay for consumption rather than capacity. If you think about an on-premise environment, you're always paying for capacity. You're buying your hardware. Okay, but really in the cloud, you're often paying for capacity as well. You are setting up an EC2, which is a elastic compute cloud, in other words, a virtual machine instance in AWS, or you're setting up a virtual machine in Azure or in Google Cloud Platform. Well, when you set those up, you specify a capacity. You say, I want this to have a certain number of processors. I want this to have a certain amount of memory, a certain capability, and you pay for that. You pay for it whether you're using all of that or not, right? But if you, for example, go serverless, and we'll talk about Lambda functions in just a moment. Let's say you use a Lambda function, then all you're paying for is what you use. Okay. And it's really kind of that next step in the progression of going to the cloud, is that if I go with a consumption model, then I am very much paying for specifically what I use, as opposed to paying for the capacity to use what I need, which is pretty cool. You want to measure your overall efficiency. Okay. And this is one, it's a little bit marketing, I'll be honest with you, but it's a valid point. Stop spending on undifferentiated heavy lifting. Okay. What does that mean? It means that in most cases, your organization is not in the business of building and maintaining data centers. You may build and maintain data centers in the support of your business, but that's not your business. And so what AWS would love you to do is to stop doing that, right? They want you to let them do all of that, right? And that goes into a concept outside the scope we're doing here, because I've already taken half an hour of your time talking about this, but total cost of ownership, okay? And very big one here, analyze and attribute expenditures. And that's something that's common across the clouds. They want to make sure that as you're spending your money, you are in fact understanding exactly where that money is being spent. Okay, now the fun part. Well, fun part for me at least, applying the framework. Okay, so that's what the framework is. How would I go about applying that to my workload? And again, I have a workload. We'll talk about that workload in just a minute. Okay, and so what I'm going to do, the rest of this is really laid out here. So I'm going to identify a workload, including what its kind of non-cloud architecture would be. Okay, then I'm going to define a high-level architecture, an initial cut of that architecture, applying the basic framework principles. Okay, so what would I change just going through the base of the framework principles, and what would be the cost of that solution? Okay, and I'm throwing the cost in there because I think that's an important part of going through the framework, that cost optimization. All right, and then I'm going to go through the well architected tool. Using the well architected tool, how good is my solution? And again, unfortunately, it's not great, but that's okay. All right. Then I want to talk about the changes, both the changes that would be made in the initial cut and what are the impact of those changes, but also the changes that would come out of the recommendations from the well architected tool. Right. So how can I make this architecture better? All right. And then I'm also going to quantify broadly the overhead of applying the well architected framework. So how much did it cost me to apply this well architected framework? Okay. All right. Oh, and by the way, completely going to break the flow of this. Sean Moriarty, I'm glad you're in Maryland. I hail originally from Maryland. I went to University of Maryland, Fear the Turtle. Okay. That had nothing to do with anything, but I saw it and I had to comment. All right. Let's talk about applying the framework. So what is this workload of which I speak? All right, it's a live quiz session. Now, I've actually built multiple iterations of this. I used to give it clever names, but then all of these really cool little apps that ended up failing came out, and they took all sorts of cool names. So now it's just a live quiz system. The idea is that you've got different actors, and I have a lot of times if you're looking at actors for a workload and you're looking at the diagrams, you can see little stick figures. I really like this little smiley face because it's very happy. It's also vaguely creepy. And I think that is a nice combination. But anyways, here's the deal. Okay. It comes down to saying, hey, I want to be able to create quizzes. Okay. These quizzes could be for IT courses, could be potentially for certification, right? But I want to be able to create these quizzes, and I want to have a system that's going to make that easy for me to do and define these quizzes. Okay. And then somebody needs to be able to say, hey, I'm going to run that quiz. So instructor can pick up a quiz. That's a terrible arrow. Okay. And then of course, once they do that, they can say, hey, we're running a quiz, and they've got participants or students or whatever, and they can go in and take a quiz, right? So I can create a quiz. I can administer a quiz. I can take a quiz. And of course, wrapped around everything, somebody has to keep this whole thing managed. And so I've got an administrator that's going in there and working with it as well, right? So, these are my users, right? And so what I said is, okay, that's cool. But what I want to focus on is, just for this, let's talk about that area that is the content creator, right? So what does the content creator do? Well, my initial architecture and say, okay, I'm going to take this and I'm going to take what I've always done with this and I'm going to put it in the cloud, right? Well, what's the easiest way to do that with the tools that I currently use now? The easiest way to do that would be to take a virtual machine, right? Which again, in the AWS environment is an EC2, load that up with Ubuntu. On top of that, run .NET Core, and on top of that, run an ASP.NET Core MVC application. Now, more than likely, I would deploy this, and I would deploy it using containers, so I don't have to worry about whether or not the core is installed. But honestly, though, still pretty much a monolithic application. Now, don't get me wrong. Monolithic doesn't mean that it's not componentized, because everything I build is going to be componentized. I'm going to build a data interaction layer. I'm going to build a modeling layer. I'm going to build a service layer on top of that, right? But it's all in one package. If I need to update it, I'm deploying that one package, because from a development standpoint, that's a pretty easy thing to do. And it's how things, if I look back at the history of building this application, it's kind of how I always built it. And supporting that is a relational database, okay? Now, also built on top of that is, a very high level flow. We're going to have developers. Developers are going to have a Git repository of some type, and there's going to be some kind of, CI/CD pipeline that is going to deliver this. Now, tons of different options for that. Again, most of my experience is on the Azure side. I've set these things up using Azure DevOps. You can use, Git. You can use Jenkins, of course. You can use Circle CI, all sorts of different tools, right? Again, the framework that I would be able to just set up and do without even thinking would be on the Azure DevOps side, but that's just because that's the tool that I've used, right? But that's all there, and it's all sort of standard with how I might build this original architecture, right? So if I was going to take what I've always done and just kind of move it into AWS, this would probably be what we'd be looking at. Now, how would I go about optimizing that a little bit? Okay, and so here's where what I did was I went through at, frankly, a relatively high level. I dug a little deep into it, but really for this exercise, I didn't need to. I went through the Well Architected Framework documentation, and I looked at the design principles across each of the pillars and said, okay, what would be a way that I could apply these design goals in these pillars to improve, to make my application more well architected for the cloud, right? And so I start out with operational excellence. And there's two things that I would apply there. First of all would be cloud formation. Cloud formation, if you're not familiar with that in AWS, it is a templated infrastructure as code system, right? So rather than going through the console, the visual UI, or even going through the CLI, or even going through the REST API to say, okay, build this and build this and build this, I define a template that says, here's what I want at the end. Let me give you this template. You build it out, right? And the thing is that the template is a file, which means that it can be included in things like a CI/CD pipeline, and it can move me towards an environment such as a GitOps environment, which, if you're not familiar, is a combination of DevOps and infrastructure as code. So in other words, I can actually automate the deployment of the resources necessary for this. Okay. All right. Reliability. Oh, CloudWatch. Sorry, CloudWatch is AWS's telemetry and monitoring system. Very big system. Okay. And I'm looking and saying, okay, I would want to integrate that into my solution. Now, there's a great question that just came in. I actually want to take that because it ties in right here, and it's a good place to tie it in. I made a decision when I looked at this process for this webinar that I am going to use AWS services. Okay, so I'm using CloudWatch, I'm using CloudFormation. Now, what that does is that ties me into the AWS environment, right? So if I have a solution that uses CloudFormation, I'm not going to be able to take that solution and simply apply that solution to another cloud. And this is something actually that we're doing a lot with at INE. And so a question came in. I want to read you the question because it's a great, as I'm going through this, it's a great thing to think about. So I just got a question that said, I don't know if we are this far into this yet or not, but if there are any tips or things to keep in mind in terms of multi-cloud solutions and setting apps up to move back and forth, can you possibly point those out as well? Yes. All right. And one of the things that I will often do, and that I'm a huge fan of, for example, is I'm a huge fan of containerization. Okay. Pretty much anything that I build, I am going to deploy, I'm going to build as a container, right? And so I could, for example, build all of the code parts of this solution as microservices deployed in containers. And I could take that container solution and I could layer that on top of Kubernetes, for example. And when I do that, what that's going to mean is it's going to mean that the code that's in my microservices, okay, is going to be deployable anywhere, okay, across any cloud, right? And so when you use technologies that are cloud independent for deploying your solutions, then you have solutions that can be deployed across any cloud. Another example, I am using CloudFormation. Okay? There are similar systems, and I kind of think of the big three clouds. I think of AWS and Azure and Google Cloud, right? All three of them have their own templated deployment infrastructure and system. Okay, there are also third-party systems. Of a common one that you may be familiar with is Terraform, right? And the idea of a third-party system like that is that I can define a set of resources that I need for my workload and conceptually deploy that across any cloud. Now, my experience has been, and I'm not a Terraform expert, is that it's fairly difficult to get that level of cloud independence when you're looking at infrastructure as code. There's just so many differences. Even though you've got virtual machines or EC2s, you have VPCs or virtual networks that do the same thing. You have subnets in both places. You have database systems in both places. The way they're implemented is different enough that it's a little bit difficult to do that. So one of the things, and the question was raised by Sean, one of the things I did for this webinar is I kind of went all in AWS as an exercise, right? And one of the things I would do in practice is I would absolutely back off of that, right? I would absolutely, well, not absolutely, highly likely, I would build my code into a containerized solution. And I would do that, again, to give me the flexibility to put it anywhere I want. Now, another thing that I recommend is when you are looking at resources in the cloud, and we'll get to this in just a moment, as much as possible, use resources that have at least an API, an application programming interface, that is going to be common not only across clouds, but across non-cloud environments as well, right? So if at some point, whether I wanted to move the solution from AWS to Azure or even back on-prem, right, the more I'm using APIs, application programming interfaces, that are not tied to a cloud provider, the easier it's going to be to move. Now, the flip side of that is, and this goes back, and hopefully I won't offend anybody. If we have Java developers out there, hear the whole story. This is not a knock on Java, but when Java first came out, it was really novel because it could run across platform, right? You could run it on Windows machine, you could run it on a Mac, you could run it on Linux, right? But of course, what a lot of people said, in order to do that, they went for least common denominator, and you could build the worst possible functional application on any one of these platforms, right? Now, clearly, of course, Java and many other cross-platform systems, I use cross-platform development. I use .NET Code all the time, .NET Core, excuse me, all the time. I use Visual Studio Code to write .NET Core, right? But to some extent, if you keep it completely vanilla, you're also potentially losing functionality that's available from the cloud itself, right? And so as an example, in this case, I'm making a decision to use Cognito, and I'm jumping ahead a little bit there, but I'm using a decision to use Cognito, AWS Cognito, as my identity and authentication provider, because it's really simple to do that. There's a simple API to integrate that into my code, which in my case would be a .NET application, right? And now what that of course means is if I choose to then use a different provider, I'm gonna have to rewrite that code. Now I could write my code more generically to use OAuth 2 or OAuth, 2, sorry. And I could do that and then plug and play a authentication provider, right? But I kind of made the decision that I'll take that trade, I'll take that dependency on a cloud provider to give me simplicity of design. And if I need to make that multi-cloud, right, then I have two options, right? I either have to look and say, okay, I need to refactor this and say I should have gone with a more generic OAuth-based authentication. If you don't know what OAuth is, it doesn't matter. It's a generic protocol standard for, well, actually, that's authorization, but then you have identity and authentication built on top of that as well. So I misuse that slightly, but not too bad. Anyways, hopefully not rambling too much. The question is very good, and it's a question that you're going to have to consider anytime you deploy to the cloud, right? There are ways to deploy code that really is complete, or solutions that are cloud agnostic, but you do have to weigh that against the complexity of building that solution, and are you getting the most out of that deployment into a cloud? So hopefully that makes sense. Great question, came in on the Q&A. All right, now what about reliability? All right, first of all, definitely implementing horizontal scale. Horizontal scale capabilities are available in every one of the technologies I selected for the solution. And in particular, I'm going, as we'll see in a minute, serverless, which is kind of by definition, it's horizontally scalable. Okay. Oh, and also looking at a CI/CD solution. Okay, what else do we have? Cost. Going to go with the consumption model as much as possible. And again, just sort of jumping ahead, all of the written code I've defined as it's going to be it's going to be implemented as Lambda functions, which are serverless functions, very, very small elements of code that you can deploy independently. They can scale, and you're absolutely only paying for what you use, which is fantastic. Definitely going to implement cost monitoring, talk about a couple of things I added there. And for everything else, monitor and scale, and as much as possible, auto scale where it is something that is reasonable to do. Now, in terms of performance, all sorts of decisions that were made there. We'll see, I'm looking at something called Route 53 to give me global presence. I'm using Lambda functions, both actually to provide a web interface as well as to provide backend processing. The web interface, I have API management. That actually should be API gateway. I apologize. Also, I'm shifting from a relational database to document DB using the MongoDB API interface. Okay, if you're not familiar with document databases, think about it's not, you don't typically use it for things like Word documents. It's taking data, but it's not putting it in a relational format. It's putting it in a document format. So I might have a document that represents a user and all the characteristics of the user. I might have hundreds, thousands of those. All right. I might also, in my case, have a document that represents a quiz. And that's a more natural and scalable solution, in this case, in a relational database. Love relational databases, but I looked at mechanical sympathy and thought, document DB would actually be a better solution for this. And I'm going to use the MongoDB API for that because that's a common API. All right. Also, simple queue service. All right. I am a fanatic about asynchronous application development using queues. Simple as that. If there's a possibility to implement a queue in a solution, I'm going to do it. And I feel pretty good about doing that. What about security? Again, also, that's a straight copy. Whoops, a little bit of an error there, sorry. Some of the things I'm doing for security, as I mentioned, I am using, so we can we'll just pretend I didn't write that there. There we go. Live presentation here. But some things I'm doing, I'm using Cognito for user identity management and authentication. I'm using certainly end-to-end, I'm using encryption at rest and I'm using encryption in transit. I am absolutely going to take a look at implementing audit trails of data updates. I will tell you, I don't have that implemented in the initial design cut, but the design cut will support that. Okay, so what does this thing look like? How do we build it? Okay, well, I start out with two components. I've got an API gateway that's going to provide the web interface backed by Lambda functions. So every request that comes in to the application, it's going to be a web-based application, all right? And I'm thinking about the workload of somebody who is a content creator, right? Somebody who's building quizzes, right? So they're going to go through a web-based interface. Everything they do is going to be supported by Lambda functions. Okay, at the back end, I'm going to have a document DB database with a MongoDB API. So I've got that consistent code. If I do want to move it, that's going to simplify that process. Okay. I also am going to implement a Redis cache solution using Elasticache, using AWS Elasticache. All right, that's going to be a caching system. It is an open source and industry dominant caching system. And again, that's something where if I choose to move the way that I cache, I can move that. If I want to move that into another provider back on premises, it's going to minimize the amount of code rewrite. So I definitely looked at that as a concept as I was building this out. Okay, in terms of data read and write, it's going to come from that. Data read and writes, if it's not in the cache, right now I've got my Lambda saying, okay, if somebody asks for a quiz, so I've got a content creator, they're trying to pull back a quiz, the Lambda function is going to look in the Elasticache, the Redis cache version of Elasticache. If it's not there, then it will pull data directly from the database. Data updates are going to be handled differently. Any data updates, right, are going to go through a queue system, so that I send an update. The update is not going directly to the database. Instead, it's going to the queue. That's going to be backed by another Lambda that will both update the database, but also update the Redis cache. So those updates are available anytime somebody wants to pull that data out of cache. Okay. And the other thing that I'm layering on top of this is I am layering my Cognito, which again, I'm using for identity and authentication to control access. I'm also implementing CloudWatch, generally speaking, and I kind of have that as just an icon out there. I think that's something that it will actually end up being a relatively significant effort. And I'll talk about that in just a moment. And we're going to go longer than an hour. I apologize. All right. Now, the other components that I've got, the CI/CD pipeline, some of you use things like the code commit, the code build, code deploy. I'm using also implementing cloud formation. These are all services that are available. I could have also said, hey, I'm just going to use Jenkins. One reason I looked actually at Jenkins, and from what I could tell, and I didn't do exhaustive research, I wasn't thrilled with its integration with cloud formation. So I said, okay, I'll just, what the heck, we're going to AWS. These are all systems that are really pretty cheap to use in AWS. So I'll go ahead and use those. All right. Now, that's my initial concept, right? But that concept looks at it maybe as just a single deployment. One of the things I wanted to look at is saying, okay, how can I build this out? How can I make it global? How can I make it so that it's going to scale in a way that goes beyond a single region? Okay. And that's where I said, okay, let's have multiple regions, and let's have these resources that I can deploy in multiple regions. And that's where doing things like using cloud formation becomes really important, because I know I can take this deployment that I have and just repeat it, okay? And then I need something to control in front of that, and that's where I would use a service, the Route 53 service, which is AWS's kind of global, I don't want to say load balancing, it kind of does that, but it's a global request distribution system for your networking requests. Okay, now there's one thing that I want to point out here. Okay, if you look, I've got my API gateway. I could deploy that in two different places. My Lambdas all over the place can be deployed. My Redis cache, my queue, right? But what you may notice I don't have multiple copies of are my actual database, the DocumentDB database that I'm using, or Cognito. Okay? Both of those, and kind of looking, and again, I haven't dived completely deep, but those are kind of region bound. Now, they can be set up across multiple availability zones, so they're very high availability. But at the end of the day, I am looking at, having to build connections between these regions, which, ideally, I'd rather not do that. And quite honestly, it would be something that would make me consider looking at a different solution. But that was really the only, if you will, what I would consider to be hiccup in the process. So this is how it architected, and I can envision knowing what my workload is, right? I know the workload. Again, it's something I've played with for a long time. 100% I could implement the workload, and in fact, eventually I will implement the workload with this architecture, okay? Now, I'm not going to spend too much time on this because I have been going for a while and I don't want to keep you all too long here. But one thing that all of the cloud providers have, and I strongly encourage you to use this, is a cost estimating tool. And it is exactly what it sounds like. It's going to allow you to say, okay, under these conditions, how much would it cost me to run this workload in your service? Now, here's one place where I have a little bit of I run up against the well-architected framework, because one of the things that AWS absolutely stresses in the well-architected framework is that you stop guessing at capacity. Well, in reality, to come up with a cost estimate, you don't really have to guess capacity necessarily so much, although you kind of do, but you have to guess at least what the load is, right? And quite honestly, I have no idea what the load is. Now, I will also tell you that that's not really any kind of, it may seem counterintuitive, but it's really not. Because when we look at the well-architected framework, they're not talking about this with the cost estimate. They're talking about this when you actually buy stuff, right? And the reality is, okay, you want to have good cost estimates, and I would recommend, this is one thing I recommend that you return to over the life cycle of your application, is simply going and running a cost estimate, because you are going to have to guess with your cost estimate because it's an estimate. All right, so what I want to do is I'll show you the cost estimating tool, and then I'll show you an example of an estimate that I actually created. All right, so this is the price calculator. And what this does is it lets you very easily build a cost estimate based on pretty much any AWS service that you want to use. Well, okay, there's 96 out of the 170, but certainly most of the normal ones. So let's take an example and I'll show you some of the options. So here is the Amazon API Gateway, right? This is one of the services that I plan on using. Okay, and say, all right, well, how am I going to use this? This unit, I can see here, select the unit's number and frequency of requests. So I'm going to say, I'm going to look at millions of requests. Okay, and I'm expecting, let's just say 10 million requests per month. Okay, and then I can say, all right, what is the average size of each request? What's the size of the request? Now, you could calculate that out. I completely didn't calculate that out, right? But that's something that could be known, maybe not right initially, but as you refine, right? And that's one of the principles is always refine. You can do that with your estimate as well. So fine, we'll go with 34. And I can show the calculation, and that's going to tell me that it's going to cost me $10 a month. Okay. Now, REST APIs, I didn't really plan on any REST API calls. Those would be automated calls as opposed to user calls. So if I want to make it so people could integrate this within their own system, I could set that up as well. And I could cost that out. And if I have WebSockets, I could cost that out. All right. And so based on what I've said so far, the Amazon API Gateway would cost me $10 a month. Okay. Now, I have actually already generated out a cost estimate. And that cost estimate comes out to be, over the first 12 months, roughly $11,000. Okay. Now, this is based on wild assumptions, but the cool thing is I could always come back and I could modify that. So, here are the different components. I've got Lambda, I've got CloudWatch, I've got Simple Queue Service, Elasticache, DocumentDB, Cognito, API Gateway. I'm missing Route 53, but that's okay. Okay, but I made assumptions about how much I'm going to use these. And what's interesting to me, based on my assumptions, I've got Lambda, which is my code, right? And that's where my code's running is Lambda. And so I assumed, I believe, 10 million requests coming in through Lambda. That if I get 10 million requests coming in, and when if I deploy this, I'm happy with that per month. Max concurrency of 100, so 100 concurrent users at a time. And I'm thinking that it's probably going to be provisioned for a total of 64 hours. That's provision concurrency. That's high level functionality that says, okay, I want to keep this thing hot and make sure it doesn't drop out of memory, so it doesn't have to get loaded the first time somebody tries to connect. Okay. And how many requests are there for that? I think it said 5 million requests. And then I've got CloudWatch, which is where I'm going to really accumulate and monitor all of my telemetry. And what's interesting to me is that the CloudWatch came in at almost 3 times the cost of the Lambda. And that, of course, it's all based on just assumptions I made. But I think they're not completely out of the ballpark assumptions. My queuing service came in at $14. The Elasticache came in at $227. And the DocumentDB, not surprisingly, was the highest cost at $400. My Cognito was free because I didn't choose to use the advanced options. And I can edit that if I were to go in here and say, I want advanced security features. My cost just went from $0 to $1,500. I just tell you right now, I don't think I could justify that. So we'll not be using those advanced features. Okay, but anyways, there you go. I have generated a cost estimate based on that design. Next thing is this well-architected tool. Okay, again, it's free. I'm already at an hour, so I don't want to keep it too long. I'm not going to go too much into the documentation. It is documented, but I thought it would be cool to show you it. Okay, so what I'm going to do is hopefully, found it. Got it right away. All right, the well-architected tool is actually built into the AWS Management Console. And if I go to the well-architected tool, okay, I'm not even going to zoom in on this because I don't want to show you how many high-risk items I have. You can see it if you look. But you can define a workload. And what this does, it says, okay, I'm going to define a workload. I'd give it a name. DM. Oh, it's got to have at least, there we go, DM2. So that's going to be delete me. I'm going to be the reviewer. Okay, this is going to be for production. I'm going to put this into, just put it in one region for now, East US. Okay, I would put in my account here. I'm not going to do that right now. If I have got a diagram like that amazing diagram that I showed you, I could put that in there. I could specify an industry. Okay. And possibly tag it. All right, next. All right, and then I said, okay, what do you want to apply? I want to apply Well Architected Framework, and I could also apply serverless, which I have in the demo I'm going to show you. Go to define the workload. All right, and so right now there's nothing, but what it's going to do, and I'm not going to make you watch me go through an hour of answering questions, but I'll show you, just get a feel for it. All right, I'm going to start answering questions, and it's going to go into the Well Architected Framework. And the first question is operational excellence. There are 11 questions it's going to ask me about what I'm doing regarding operational excellence. Okay, then after that, I've got, and it doesn't quite show everything here. For some reason, it only shows 4, but there will be, the cost optimization is there as well. But you can see I've got questions for the others as well. Okay. And then, so the first question, how do you determine what your priorities are? So what's your process for determining priorities? And, what am I going to do? Say, okay, I want to definitely, my external customers, I want to find out what's going on there. We don't believe in governance. I mean, the reality is for this one, probably aren't compliance regulations, right? But these are the things, and you'd go through here and you'd be honest. What are the things we've thought about that we already have architected out? Okay, and so you would go through that for each one of these. You can actually put in notes as you go, and then I go next, and that's going to carry me through the whole process. Now, in addition to the actual questions, right, and it's more than just 10 questions here because each one of these has multiple parts. Okay, each one of these little parts, and this I think is super valuable. I've got right here info. Okay, so resources have identified owners. I'm new to this whole thing. What does that mean? I click info, and it brings it up right over here, and you can see exactly what they're talking about with links to references, right? And so what you're doing is, you're not only building kind of what this report is going to give you, the recommendations, but you can do a lot of learning directly from this tool. And I think that's pretty cool. Like, I don't necessarily need to go into, days of studying the documentation. That's not a bad thing to do. Okay, certainly I say at least look at the design principles across the different pillars, right? But as you go through this, if you're not sure, you don't have to wait for that to start this process because you can learn a lot while you're doing it. I did. I learned a lot while I was doing this. Anyways, that's kind of the thing is I would go through this whole process. Okay, but I've already done that. And I've got quiz management. And you can see it's okay. I have completed one question and I already have one high risk. Now, if I go to quiz management, yes, by the way, 2 questions in there in the Q&A. Can you make the slides available prior to the video? I'll check on that. Technically, I mean, if it was just my content, sure. But technically, this is INE content. And honestly, I've been asked that question before and I can never remember. I'm pretty sure I can make it available to you. And if I can, we'll get it out in your follow-up email. Okay. But yeah, you will be able to see everything. The video is absolutely made available. It does take a little longer because it is processed. Can you briefly, there's a follow-up question to that. Can you briefly display the slide with crossouts? I'm not sure which slide you're referring to, but absolutely. I'll ask you when I put it up there if you text me if I've got the right one. Okay, let's go back to my report here. Okay, so here's the report. And I'm not going to do everything. I can actually continue reviewing. I can edit. I can change my answers. But as it turns out, when I went through and I answered this relatively honestly, my great design that I'd come up with ended up with 31 identified high-risk issues and 18 identified medium-risk issues. Now, I will tell you, it's not as bad as that, because quite frankly, with what I'm looking to deploy, not every recommendation applies to every scenario, but it's good to have them all. And, unless you have a good reason not to, it's probably a good idea to try to follow them, because again, these aren't things that were just made up. These are, an expert system designed by experts with lots of experience in building good applications. Okay. And then it goes, okay, here are the two lenses I had selected and how my issues break out. And what I can do is I can drop down into one of them. So this is the overall well-architected framework. And I have 30 high risk and 15 medium risk. And I can go in here and say, okay, so here are the areas that were identified as risky. Okay. How do you securely operate your workload? I didn't answer that one real well. How do you manage identities for people and machines? It called me to task a little bit for that. So I said, okay, how would you suggest that I fix this, right? And so these are all of the suggestions that the well-architected tool has for me. Okay, and I'm going to take a look in just a minute. Okay, fine. How did I apply that to my architecture? And we'll look at that. But that's the basic idea there. And I can go through a number of security-related questions or recommendations, and then there were some reliability recommendations as well. Okay. And so that's what the tool does for you. Again, you're going to go through, and I'll tell you, it took me probably about an hour, taking it kind of seriously, not having a real application, but taking it kind of seriously. It took me about an hour to go through. That's not terrible. And I've got this set of recommendations that legitimately could make my system better. Okay. All right. So that's the well-architected tool. Now, then the question is, that's all well and good. Okay. What did I build? Okay. And I'm going to show you, I threw this up here because it's a little bit of vanity on my part. But I will tell you, I was like, okay, again, let's take a look at this. Let's take a look and see how much it's actually going to take me to do this, right? And I looked at two things I had not used before. I used other versions of them, but I had not used them before. I looked at code commit, right? And I looked at CloudFormation. And what I built between those, let me pull this up real quick. Okay, if I go to, we'll go to code commit first. Okay, so I went into code commit and I created a repository. And it took me like pretty much no time to create the repository, right? And it's a Git repository. I know how to use Git, but I wasn't exactly sure how to actually set up the credentials for this. It took me 10 minutes of doing a web search. How do I set up credentials? And it turns out that in order to get the credentials for that, I need to go to IAM. That's my identity and access management. And under a user, breaking all kinds of security here by even showing you this, but that's okay. You're a paying customer. It's all good. Okay. But basically what I have is I can set up my own Git credentials, which I've done. Okay. So I set up a repo, I set up my credentials, 10 minutes of research, probably less than that. And I've got literally everything I need to set up Git. In fact, I've done that. Okay. The other thing that I did was I played around with CloudFormation. So, okay, what would it take me to actually get this template that I could use eventually to deploy this whole thing automatically into AWS? Okay. And so I looked into CloudFormation, and I earlier today deployed what's called a stack. And I'll show you what I used to do this because I have the template is in my code commit, and I've pulled it down into my local machine. And so I can show that to you. And that's kind of that whole flow that I would expect, right? And so I have deployed some of my resources. And if I go to template, here's the template that I deployed. I created this template, and I can actually view in Designer. And literally, this is, like I said, this is what I deployed about 15 minutes before I started. Zoom in a bit. Now, this is not everything, but it gave me a pretty good feel. And it's a fair bit. So I have a VPC, virtual private cloud. I've got some subnets in the virtual private cloud. I have a Elasticache solution with Redis cache that is tied to a private subnet, and actually two private subnets. Also has a security group to control access to it. I have a cluster solution, a document DB cluster, also tied to some subnets. These are private subnets, so I'm already segmenting my network traffic away from the data as much as I can. And I have a queue set up. Now, I didn't add some of the other stuff. I didn't add API gateway. I didn't add my Lambda functions, which can be by far the most interesting. But again, I just kind of wanted to get a feel for what this would take. Okay, and so I deployed that. Now, I put both of those together, and okay, what I have here is I've got Visual Studio Code, which is the tool I use for pretty much everything. And I pulled down, I cloned the repo that I've got in AWS Code Commit exactly the same way using Git that I would clone if it was in GitHub or my own Git repository. And it's got this file. Now, out of certainly anything I did in preparation, this file took by far the most time for me because it's just something I'm not used to. I don't have the tooling for it. This is something, if I was doing the same thing in Azure, it would have taken me a fraction of the time just because I've got the experience and so on. But I really went into this cold and I said, it's time for me to learn CloudFormation. And I put it together, and it's not comprehensive. I didn't do certain things like mapping because that was just going to be a whole lot of definition that I didn't want to deal with right now, that I didn't need to deal with, but I would. Anyways, so I was able to kind of, mostly going through AWS's documentation, build this up. All right. And so again, not going to go deep into this, but this is the CloudFormation that I did. So those are kind of the first things that I took a look at to kind of build this up and look at and say, okay, how feasible would this be to do? And then what I did is I'm going to say, okay, what are the changes that we can that would happen because of this, right? Taking that original document, and I'm not going to go into all the details again. I've just been told that we can share the slides, and I'll get with my folks to make sure that I've got that the right way. So I'm not going to spend tons of time on this, but I did think it would be interesting at the very least to take a look at this. So here are the solutions initially. I checked DocumentDB, Simple Queue Service, Elasticache, API Gateway, Cognito, CloudWatch, CloudFormation, and Lambda, right? Beyond the actual price estimate, I was like, what's the impact of this? What is this going to do to my development workflow as I build out this workload, right? Well, the DocumentDB, in reality, that's a positive change that is needed to happen anyways. DocumentDB is a more logical platform for me to maintain the data that I'm maintaining for this system, right? And so, honestly, it was good because looking at the mechanical sympathy, aside from the fact that I love that phrase, it really made me think, say, okay, I need to make this change. It's time to make it. Cool. SQS, all right? This is minimal. Cross that out. Didn't mean to cross it out. It is minimal. Check mark it. And I will tell you, I've done a lot of this where I've taken synchronous, tightly coupled operations and I've transformed those into asynchronous, loosely coupled using a queue. And I can get that down to where I have to add about 6 or 7 lines of code to make that happen. I have to add some libraries, but that's really a pretty minimal impact and something that's absolutely worthwhile. Elasticache, also minimal. Impact of that, very minimal, because I can use a Redis API, which is very common. It's well supported within .NET Core, which is what I'd be building this in. And so just minimal. API on the dev side, API gateway, that's one of those things where it's almost probably should have just said positive. There is impact. There's operational impact. Somebody's going to have to set that up and run it. But it takes care of a lot of the things that I just don't have to worry about, giving me the opportunity to run a web application as a serverless web application, which is pretty cool. All right. Cognito. All right. I put that as NA, not applicable. I needed an identity and authentication service. And I promise you, I've built them from scratch. There was no way I would build that from scratch. Cognito is a nice plug and play. There's some coding involved, but that to me doesn't really impact because it's just something I would need to add in no matter what. CloudWatch. I put CloudWatch as medium, right? Because I think that instrumentation and telemetry is vitally important within applications. Now, if I were doing this in Azure, it would be none, because I know the tooling to say integrate with their version of this. It's built in, I can click a button and I've got telemetry, right? CloudWatch though, realistically for me, is gonna be a little bit of effort, right? What am I gonna have to put in to do that? So there's a medium impact. CloudFormation, same thing. No experience with CloudFormation prior to this and how that interacts with GitOps. I did a little bit of it, right? And I, was able to build a template and deploy a template, but it's not automated, right? I don't have that tied into that whole CI/CD pipeline that I can build. So I think that would have a little more of an impact. And the highest impact of anything is the conversion over to Lambda. Now, I've done Lambda functions. They're not difficult. They're fantastic. But on a scale of actually deploying an application, it's not something I've done. Getting the code there, automating the code, testing it, setting it up, making sure it's right. So for me, that's something that would be definitely a higher workload. Again, I've done that on the Azure side using what are called function apps, right? But it's a different environment. So I thought that would probably have more of an impact. All right, now what about the review? Not going to go into all of these because I don't want to put anyone to sleep, but there were a number of things that came out of that review that I looked at and said, okay, these are things that I need to implement. And one of the things that, I would really want to do is say, okay, what is it that I need for my, minimal viable product, MVP, common term, okay? So what are the things I would say, look, before this thing goes into MVP, I've got to have vulnerability scanning and software validation absolutely at least know that I can plug that in, and I should have that plugged in before I try to go public. 100%, and I don't just say this because we have a very robust security training system over here. Definitely want to make sure that's in there for MVP. Credential management, and again, that's kind of just I went very vague on that. That's internal credentials for the way that, say, for example, my Lambda function communicates with the queue or with Redis or with DocumentDB. Definitely want to have a system in place to manage that. Operational access requirements, probably not necessarily for MVP. Planning incident detection, probably not MVP, although critical. And I'll probably, if any of my security colleagues see me say that, they're going to come at me. I would say I want to definitely spin up a web application firewall and rules. Okay. Network inspection, probably not critical. On the reliability, that is something I already knew about. Definitely want to take a look at this one. Maybe not for MVP, but automating responses to issues with my metrics, right? So if a metric comes out of range, obviously I want to get alerted, but also is there something I can do in an automated way to help bring that in? Really, most of these things, most of the rest of this are things that I wouldn't necessarily need for what I would consider to be MVP, but absolutely they would go into my backlog as issues that 100% need to be addressed. Okay, so those are the changes, both the initial design changes and then after going through the review that I would make to my overall process. Now, what about the overhead? So what is the overhead that this generates? right? And in terms of time, and that's where I really wanted to look at this is, okay, what is, the impact, the time impact that it's going to take to that this is going to add, right? So if I were to just go and bang this out, open up Visual Studio Code, create a ASP.NET Core MVC application, bang the whole thing out, where do I add here? Okay. Cloud practitioner, first thing, and that may seem weird that I was like, okay, getting the cloud practitioner, I counted that as overhead. It kind of is, because I needed to know what Simple Queue Service is, what Elasticache is, what Document DB is, what Route 53 is, right? And I put probably 2 to 3 weeks of prep. It's kind of hard to say, and that's certainly not going to be universal. I think it was a bit easier for me because I already had tons of cloud experience. Okay, going through the Well Architected Framework overview, I ran through that in about an hour, but I think realistically, to go in to do it right and to then, kind of take those recommendations, my 31 critical and 15 or whatever it was, medium risk, right? Build those into my architecture, build those into at least the backlog and triage those a little bit. I think that would be at least 4 to 6 hours. Cloud formation, I will tell you, it took me to get to where I was from nothing, took me about 8 hours. Building the cost estimate, maybe an hour, probably less. Using the well architected, these kind of go together. So between understanding the well architected framework and using the tool itself, probably 6 to 8 hours. Okay. Now, the AWS CI/CD, I put in 2 weeks MVP. I think that's probably an overestimate at minimal viable product. And the reason I say that is from experience on the Azure side, because I literally went through the same thing and said, hey, I'm in Azure. I'm going to use Azure DevOps. Haven't really done a pipeline for it. Let's do it. And I definitely had it completely operational in under 2 weeks. Might have been closer to a week, but we'll throw 2 weeks in there as kind of the overhead. Honestly, I'm looking at that architecturally, to go from not having a cloud architecture to having potentially a really solid cloud architecture, that overhead is nothing, I think. So, that's honestly one of my takeaways is, and this is a little simplistic, but yeah, do this, use the tool, learn the well architected framework, because it's not a huge investment. Okay. Now, what about, okay, so great. I went to this new architecture based on the well architected framework and the well architected tool. What's it going to take me to get there, right? What is this going to add, not just to the architectural process, but to the development process? And I will tell you, these are all honestly guesses, right? A little bit of experience here, but somewhat guesses. CloudWatch, I estimated 1 to 2 weeks. Again, because what I'm going to do is I want to make sure that I'm defining metrics. I'm defining the right metrics. I'm defining them the right way. I'm capturing them the right way. I'm categorizing them. They're set up so that I'm going to get, the right reporting, the right dashboarding, the right alerting. So that to me is pretty important. I mean, I think you could go through a tutorial in an hour to, say, oh, look, I can get a metric up into CloudWatch. But I think to get it right, I said 1 to 2 weeks. Cognito, I said 2 to 4 weeks. That's probably, again, a little bit on the high side. But, I feel like realistically, identity and authentication services are really important, and you want to make sure that you're rock solid. So I threw that in there. For both Elasticache and SQS, I put negligible time on both of those, just because it is kind of negligible. My team, me, I know how to use queue systems. I don't anticipate that using SQS is going to be fundamentally different than using queue systems that are available on the Azure side. Elasticache is using Redis cache. I know how to use that API. I know how to integrate it, right? I've done that. So that's, for me, nothing. Document DB, I wasn't really sure. I haven't used it. It does use the MongoDB API, but I've done document-based databases. I've touched MongoDB, but I haven't really hit it hard, so I couldn't even give you that one. The biggest one, I think, is Lambda. And I said 2 to 4 weeks for minimal viable product. And The reason for that is I build my apps when I build them. They're componentized anyways. And like I said, it shouldn't be that hard to plug in, but it's just, I would want to make sure I get that absolutely right. So I built that in. But even if I look at this, right, and I look at these, think about adding these times to the build, right? If it's one person, okay, you're talking about what, adding maybe 2 months to the overall build to get something that goes from not being cloud architected to being something that is cloud architected. I think that's totally worth it, right? On the other hand, and I'm not saying it would only take 2.5 months. I'm saying that's what you would add to the overall development time, right? But if you're looking at this from the standpoint of having a team, right? I mean, conceptually, you're talking about maybe as low as a month. All right. If I can divide that up across a team and do it efficiently, then we're not really talking about a huge amount of overhead from this. And and this is it. Now, I do want to go back. The slide with the crossouts. I assume you mean the one I crossed some stuff out. I will go back to that. But I do want to kind of come with a bit of a conclusion. And that is, I probably expected this coming in, but is probably the cost benefit of running this was better than what I expected. Right? It's really the principles are not that difficult to get behind. The tool is definitely comprehensive in terms of architecture, right? And the other thing is, architecting in and of itself is hard, right? I mean, it's kind of easy to bang out code. I think of an idea. I'll be honest with you, I don't really want to architect. I just want to go bang out some code because that's the fun part. Architecting is kind of hard. And the cool thing about this is, quite honestly, it's a tool that's going to make the overall architecting process easier. Even if I just didn't try and do anything before I went to the tool, I'm going through and I actually did this. I didn't show this to you as I was going through the questions though. I'm going through the questions and there's a place to take notes. I'm like, oh man, definitely have to think about that. Got to put that in there. Got to put it into the architectural plan. So, I mean, it's a way to kind of start to build your architectural plan just, at zero net cost, if you will. So there you go. That is really what I want to show you and kind of hopefully get you familiar with, the fact that we have this framework out there, this well-architected framework. It's this thing from AWS, but I wanted to say, let's look at this in a practical example and what's the impact? And the impact is, shall I say, significantly positive. All right. That is it as far as my content. I do have the one thing, wanted me to display the slide with the markups. Actually, let's see if I can find that over here. I think that's the one you're talking about. Let me know either in, this question came from David Klein. Let me know either in the chat or in the Q&A if this is the slide you wanted to see. Otherwise, if anyone else has any questions, now's a great time to ask them. I'll be happy to take questions. Otherwise, if I may lean upon others in the company, see if our esteemed PR director is on that might want to have a word and close things out. Otherwise, I will be happy to do so. All right, looks like I get to do it. Okay, so I'm going to go ahead and close things out. A couple things I do want to point out. This week, and I didn't really throw this out there at all, this week is Cloud Week. If you registered for this webinar, now I know that this webinar is going out through our typical webinar, which is Zoom interface. We also have it on Facebook Live. But if you did register for this through Zoom, then you have been entered into our drawing that we're going to do at the end of this week for some cool prizes. I know the big prize is a premium, I believe it's a premium 1-year subscription that one person is going to win. We also have a couple of exam vouchers for the eLearn security exam. So if you're on the security side, that would be great. Even if you're not, hey, free exam, maybe you get your EJPT, which would be fantastic. Also tomorrow, come grill us. I've got at 11 a.m. Eastern Daylight Time, we're going to be on same platform. We're going to be just an absolute open Q&A on Azure. So if you have some questions on Azure, you want to come in, that's really where my area of expertise is. I'd be happy to handle any questions you have. It'd be great to hear them. Love getting questions. And then at 1 p.m. Eastern Daylight Time, and for reference for anybody, it's 12:30 p.m. right now. So you can do your clock synchronization. We actually have, I didn't really bully. I asked our newest team member to come and be available for a Q&A on AWS. And so we have newly hired great AWS guy, Brooks Seahorn. And if you've got some AWS questions, he's actually on the road. And he had a trip planned, and he still was happy to come in and do an hour and answer some questions. So please feel free, stop in tomorrow. Again, if you register for either of those or both, you're also entered in our drawing for those really cool prizes. And I believe that is all I have. I don't see any more questions. Again, we will absolutely get on getting the slides out to you as quickly as we can. Also, do want to mention that, and I kind of mentioned this before, that you'll get a follow-up email, and we will also, might be one or two, I'm not sure, and there'll also be a link to the recorded version of this webinar. So again, thank you all so much for coming out and being a part of this. Hope you learned something, and I hope you have a great rest of your day.